Welcome, welcome. Hello, everyone. I'm so happy and excited to have you with me. Today, we're going to be doing a technical stream on prompts, everything about prompts, from what does a good prompt look like, how do we do prompt engineering, to can we automatically generate prompts, and maybe how do we evaluate them. So we're going to go through loads of stuff today. It's going to be really nice and beginner friendly. So if you're kind of new to this GenAI stuff and it's all feeling a bit scary, don't worry. I'm going to take things slow. It's going to be super fun, and by the end of it, we're going to be writing really great prompts, and hopefully we'll have a little pipeline for generating even better prompts automatically and evaluating them. So hopefully we get there. But yeah, for now, I'll give it a couple of minutes before we get started, just to allow people to join. In the meantime, please do check in. I'll throw the link up on the screen. Let me do that. There we go. It's also in the chat. Both on YouTube and Twitch. I'm drinking hot chocolate this morning, which I'm enjoying. It's very good. It's very warm. Sorry, I keep saying this morning. I mean, it's not that early. It's 9 a.m. in the UK, but it feels early to me. It feels early to me. So if I'm a bit groggy, you might have to wake me up, everyone. But together we will do this. I'm so excited. Tell me how your day is going. Whether you've maybe just woken up like me, maybe it's afternoon for you, maybe it's very early morning. I think if you're over in North America, it's probably really early. Hot chocolate indeed, yep. Is anyone else Has anyone else got a beverage of choice which they're sipping alongside their coding? I'd love to hear it. I'm not a coffee guy personally, so hot chocolate is my go-to. But occasionally I'll go for a tea. I do like a good tea, cup of tea. Yeah. And my mug today is hackathon mug. Let's see if we can get that on the camera. Oh no. There we go. It's from my home hackathon. Camera doesn't pick it up very well. From my university. So it's good memories, and hopefully it will motivate us to write good code. We'll see. We'll see how it goes. It's afternoon for you. Wow. Yeah, I mean, it's crazy. Time zones just blow my mind that people are living at just different times of day all the time. It's incredible. It is incredible. Okay, well, I think I'll slowly get started then. As always, at any point, if I'm going too fast, tell me to slow down. If something doesn't make sense, tell me to explain it. I'm here for that. I think with that, we'll kind of just get going. If you haven't checked in, check in. Yeah, I think we'll get going. I'll put some music on as well. Let's see if we've got anything not too kind of aggressive, because I don't want to overly kind of shock myself this early in the morning. Cool, this looks good. Yeah. If that's too loud, let me know. And also, as a heads up, when I'm looking this way, I'm reading the chat. When I'm looking this way, I'm looking at what I'm showing on my screen. So if it looks like I'm not looking at you or something, don't worry, I am. But I think with that, we'll kind of get going. The music's too low. Okay. I'll tell you what, I'll turn it up. And then you tell me, like, does this sound okay? This is good? I feel like this is groovy. I'm enjoying this. Yeah? I'll take that as a solid endorsement that this is perfect. Okay, right. Here is my screen, which I thought I was already sharing, but I was not. So there we go. Oh, my voice is too low. Oh, I don't know if I can up my voice. I can turn the music down. Yeah. I tell you what, give me a second and I'll see if I can increase my volume. Is this better? How does this sound? Let me know if this is too loud or too quiet. I've turned it up by 30%. So hopefully this is good. But again, just stop me if anything is unclear. So I've got VS Code open, but actually I think before we hop into VS Code, this is good. Okay, cool. Before we hop into VS Code, I think we should talk a little bit about what we're going to be doing today and why and all of that good stuff. So I guess there's a few different things that I want to go over. The first is generally, like, what's the point? Why do we care about prompts as a whole? The next thing will be like, okay, well, now we care about prompts. How do we write a good one? Is there a way that we can do that as people and do that efficiently? Is there some method? And I've got like my little idea of how I think it's good to do it. So I'll talk through that. And then maybe we'll talk about, okay, well, now we've got it so we can write it by hand, but is that actually efficient? So we'll talk a little bit about the limitations of that, and motivation to look at more advanced automatic methods. We don't care about prompts until we see we get bad output. I think we'll get into this, but I think, yeah, this is an interesting point. Potentially true, right? Like, so if you've got a maths equation that you want your LLM to solve, and you just say, solve this equation, you give it the equation, and it solves it. And then you can check that it solved it correctly, right? You've got some methods to check it, right? You can maybe substitute your answer back into the equation or something, right? Then sure, right? Like, great. We didn't have to faff around with making a good prompt. But sometimes you'll have questions where you can't check the answer so easily, certainly not so quantifiably, right? So for example, let's say you wanted to write you an email. You might say, oh, write me an email which says this, and it will write a perfectly okay email. but you might think like, oh, this is good, and it might be good enough, but it might not. You might not realize. Certainly, if you were doing something in like a domain or an area which you're not very familiar with, right? So suppose that you wanted, I don't know, you wanted it to write an email about, I don't know, frogs and frog ecosystems, right? I don't know anything about frog ecosystems, but this LLM might write something and I might look at it and go, oh, this is great. This looks really good. But I don't have any idea really, like I don't really know. And so if we are already using a good prompt, especially in cases when we're not really sure about how much we can check our answer, it seems sensible to, you know, start off strong, right, with a good and well constructed prompt to kind of maximize our chance of actually getting something useful as an output. And in general, I would say if you're using an LLM for something unverifiable and important, it doesn't matter how good your prompting is, because you need some degree of certainty around how good your result is. But certainly starting off right with a good prompt, I think, is important, and it will allow you to iterate much more effectively to get good results. Cool stuff. So I think that's hopefully helpful. And yeah, as I was saying, we'll talk a little bit about what a good prompt looks like, and then why we might not want to write them by hand. And then we'll talk about some different methods which exist for writing prompts automatically. We'll talk through one in particular, and then we'll talk through, okay, how can we now evaluate this? And we'll build a very simple pipeline to evaluate it. The pipeline can take a little while to run, so hopefully we'll get to that point, and then we can have like a slightly more chill time towards the end of the session where we just chat through what we've done, and as it runs, everything will be good. So I think without further ado, we should get started. So I kind of guess maybe the first thing to mention, and this is probably obvious, right, is what is prompt engineering? And I'm going to pull through some notes which maybe are helpful to talk over. Prompt engineering is just the construction of prompts, specifically a strategic construction of prompts for language models, right? In this case, we're looking at large language models. And the goal is to, like it says here, elicit useful, specific, or there we go, or structured responses. And like I kind of already explained a little bit, right? Like a bad prompt might be like, what's the answer to this? And then you might stick a math equation in or whatever. And then a better one might be, okay, we want the answer to concise, let's say that. And then maybe a really good prompt, and you've probably seen some of this. We might say, you are a helpful assistant. Given the following context in question, respond with a one-sentence summary, and then we give it some context and we give it a question. And when I'm, you know, constructing prompts now and then, I will do this kind of thing, right? I will often break up the prompt into like specific context or like explanation or background information sections. And the reason for that is because, especially if you're doing, like, for example, let's say you're working on a project where, I'm trying to think of a good example now, but where your kind of area, your problem has a similar name to something else, right? Or potentially there's lots of different methods. So let's say you are writing some code for, I don't know, a deep learning course that you're doing online, right? And you want to build a generative model. And you might be like, okay, well, there's a bunch of different generative models, but I specifically want to use a GAN, right? You can then give it that background and say, oh, I want you to do this. This is the kind of like structure of whatever, right? And by giving the context, you avoid it from using a method maybe that you don't want it to use, or one that might even not be appropriate, right? So let's say that you are building a classifier. If you just said, write me a machine learning classifier, it could do a whole number of things, right? And, you know, it might well not make it multimodal, for example, but let's say you actually wanted to classify images. Well, that's an entirely different problem, right? And so context is super important. Again, like here, so what we've done is we've got a role, we've got some kind of precursor, and then we've got like a restriction, some kind of clarification of what we want the response to look like, so a one-sentence summary. And that can be very important because you can prompt a model with the same thing many times, and if you don't give it some kind of clear idea of what the response should be, you could get a huge variety of responses. and that's maybe not desirable. Maybe, especially if you're building an app, you want output from your model to be consistent or predictable to some extent, right? So let's say you're building an app where you help users make life choices, right? If a user says, if a user always gives two options to your model, A and B, you don't want your model saying, well, do a combination of A and B, really, especially if you just want it to be like a binary choice. And so you might say, let's not do that. You might say, make sure that you only pick A or B and make this clear at the start of your response, right? For example. Cool. So having a little bit of a think then, like we discussed, can we do all of this manually? I mean, like, sure, we can, one-off now and then, right? If like I said earlier, if I just want to build like a very simple machine learning classifier, and I'm not going to be doing that a whole bunch of times in lots of different ways, like I could just write a good prompt. And even if I was doing exactly the same thing in lots of different times, but slightly different models, I could write a really good prompt that I could then adapt, right? And that would be, I guess, a way of kind of making it slightly more automated. But feasibly, there will be problems where you need to prompt a model and that you don't have any kind of like prompt overlap. You don't have any good prompts which you can just like borrow from. And so you're going to be producing new prompts each time. And there's a few different reasons why we wouldn't want to do that. These are kind of listed here, but the crux of it is that it's not very scalable and it will take you lots of time, right? So it's onerous and non-scalable. But actually also, I think this is possibly something that's spoken about a bit less. Like, it's a little bit subjective. As a person, you might get a different prompt to someone else, right? That's pretty expected. And you probably will get different quality. If you're all kind of really good at prompt engineering, yeah, maybe you'll get kind of similar results, but you certainly might get quite different styles of outputs and things like that. And so potentially, if you're building an app where you want users to interact with a model and you want them all to get kind of similar and consistent outputs, even though they're doing the prompting themselves, you might want to have some way that you process their prompts automatically to synthesize and generate better ones. Welcome to everyone who's joining, by the way. I'm really excited to see some more people. College Park is a UMD student. Awesome, welcome. I've got a quick question here. Which model are we talking about? Because the prompts differ between models. Can't use the same one and expect the same output. Yeah, so at the moment, I'm talking generally. Definitely we will be using Gemini later. We might use Gemma, which is the open source model from Google. It depends on how close we get to the prompt quotas. Because we're doing some like automated prompt generation, we can rack up requests pretty quickly. So we'll talk about that in a bit. But yeah, it does vary a lot between models. That's a really good point. And you might want to, when we build this pipeline, you might want to try it on some different models. We're going to be using Gemini because it's free. But you may well, if you've got access to some credits or even some compute, right? Maybe you've got access to a compute cluster and you want to run an open source model on this pipeline, you can do that. So yeah, feel free to test it out after the stream on a bunch of different things. Cool. Okay. So, like we discussed, manual prompting might be a bottleneck, right? Automating it allows us to basically get better prompts. It allows us to do things quicker as well, and hopefully it will allow us things to get results which are slightly more consistent. Yeah, I think that's pretty intuitive. We've got some like definitions here. We're actually just going to ignore them. I think that's pretty okay for now. Awesome stuff. So we've covered kind of what prompts are and why manually doing it might be good or might not be good. I think we'll talk a little bit later about the tools that we've been using today. I know someone's already mentioned the model, but basically this is going to be a really kind of friendly Python workshop. So we won't be doing anything really beyond that. We won't even be building a front end. You could shove on like a Streamlit front end or something. But for now, we'll stick to just building a pipeline and seeing if it works. Awesome. Okay, so before I get stuck into actually going through any of the methods that we're about, I think it would be worth us talking about prompt engineering almost from like a 101 perspective. what makes good prompt engineering? And once again, I've got some notes. So let's take a little look at what makes a good prompt. Specifically, we want to kind of work out, okay, after this section, we want to be able to know, is this a good prompt? Is this a bad prompt? And if we do think a prompt is bad, why? Can we clarify and state weaknesses or limitations explicitly? And if we are able to do that, we will be able to write better prompts. So we have already started this stream. We started 18 minutes ago. But don't worry, we've just been kind of going through some introductory material on prompts. The TLDR to this point is prompts are useful. Good prompts get you better results. It's worth taking the time to learn how to write good prompts, but sometimes we need to automate it because it's not very efficient doing it by hand. That's the summary. So don't worry. Now we're talking about what makes a good prompt and how we can write a good prompt. And this is my little summary here. So we want our prompts to be contextual. And we discussed that earlier. If I scroll way back up. No, did we? We did. Yeah, where is it? Where is it? Okay, yeah, we discussed it here, right? Respond with a one-sentence sentence summary, context, and then we get some context, right? So making your prompts contextual is important. Making them clear. So we discussed this as well, right? Building a prompt which has an expectation for the output, for example, is helpful. And that kind of ties into being specific, right? We want boundaries on what the results and output should look like. And I guess part of being clear is defining exactly not just what the output should look like, but also more generally what you're trying to solve. So if you are trying to, like our machine learning example, classify images, that's very different compared to classifying the sentiment of some text, right? So it's worth being clear. Next up, we've got aligned with model behavior. So this is, I suppose, one of our friendly hackers was talking about this. When we use different models, we're going to get different results, and we should bear in mind what models we're using. Oh, excuse me, drinking my hot chocolate. So yeah, and it was a really good point, because actually, yes, we do need to leverage what the models are good at, and this will vary from model to model. I haven't had a ton of experience using many outside of GPT and Gemini. I've done some stuff with Llama, but if you've got familiarity with a bunch of different models, maybe you already know, okay, this one really struggles with writing longer segments and we should break up our prompts so we do it section at a time. Or maybe this model is really good at creative work but struggles with the mathematics, right? Whatever. And there will be models which are better or worse at different things, right? I know that OpenAI have different models. Like you've got, I'm trying to remember what they're called, but you've got like the coding high one and things, or something. So there are like different models out there which will be like specifically good at coding or specifically good at reasoning, right? Reasoning models obviously behave very differently. And chain of thought is going to come into effect as well when we're looking at prompts. And finally, how measurable is our prompt? Can we actually evaluate it? And this is something which, again, I touched on right at the start. It's all well and good saying, okay, well, we'll just write a prompt if we're happy with the output. Great. But are you happy with the output? Are you actually convinced that the output that you've got is good? If so, probably what you've done is you made a measurable prompt, and that's already on the way to being a good prompt. So perhaps you've written a good prompt without realizing. But if your prompt is not, or if your output is not immediately measurable and evaluatable, you maybe need to have a deeper think about it, right? So this idea which I was discussing about, okay, let's say we want to write an essay or whatever on frog ecosystems. I think I sent an email. I don't know anything about frog ecosystems, but maybe we would want it to produce references and citations, right? And in that way, we can evaluate it. We can look through and say, oh, yeah, what is said in this link, this source that it's provided, is actually true. And that also, again, loops back into, can this model reference and cite things? Can it access the internet? Does it have search functionality? All of these things. Cool. Now, actually, yeah, let's talk a little bit about different examples of prompts. I mentioned kind of sentiment analysis earlier, and this is a really simple example. And transparently, I think any model that you run this on will be able to do this with absolutely no problems. So even a bad prompt will be fine for this, but I think it's a useful analogy. Let's talk about it. The first thing that we mention here is an instruction input pattern for a prompt. And this is where we have some instruction that remains consistent, and then an input which maybe changes, right? So let's say you are writing an app and you want it to classify the sentiment of a sentence, right? We have an instruction that is not changing, right? Every time anyone uses the app, all we wanted to do is classify the sentiment of the sentence. And for simplicity, let's say positive or negative, but you could make it, more expansive, right? You could ask it to classify into a whole bunch of different buckets of emotions. And then the input is the thing that changes, right? So this is maybe you've got a user and they put in a sentence and it classifies it for them. This is what changes. And so when you feed a prompt in to the model, the user doesn't see any of this. They just type this and click enter, and then they get the output. But what you're actually doing is you're wrapping it with this structure, this instruction input structure. And what I'm going to do, I did a stream last Global Hack Week on fine tuning, and we used a fine-tuning data set with this. Find it. We used a fine-tuning data set with this instruction input structure. Classically, it's not coming up. Give me a second. It's in my notes somewhere, so we'll find it there. Nope. Okay, it's not in my notes on... Oh, no. Okay. This is maybe a lost cause. I don't think I have it. You know what? I will try and find it. Let's see. This looks good. Okay. I'm nearly there. Take this moment to have a sip of your hot chocolate, coffee, tea, juice, milk, beverage of choice. Okay. Right, perfect. So this is not in the exact kind of detail that I wanted, but let's talk about it. So hopefully you can all see this. Yes, it has. Okay, so this is a guide on fine tuning, which is helpful. It's from Weights and Biases. This isn't actually the guide that I was looking for, but it mentions what I want to talk about. So it mentions this alpaca data set, and this was a data set created, a synthetic data set, so generated by OpenAI, well, using OpenAI from some Stanford researchers. And it generated instruction input-output pairs. And this is the actual page for it. I would recommend giving it a read. It's pretty interesting. And it's a good structure of data set for producing good results. And when you're fine-tuning, you need to have like a very particular structure that you follow, because if you're going to start changing things post-training, you're going to get like varying and possibly bad results. So that's worth bearing in mind. I think actually also, if I head on over to my GitHub, I have an example of a data set that looks like this. It should be about... Yeah, let's do it. Okay, so if we head along to, I think this. Yeah, okay, so this is an example of these prompts which I was talking about, right? So this was a workshop that I did last Global Hack Week, last month. You can check it out if you like. It's an introduction to fine-tuning. I think there are some other people doing fine-tuning this week, so check them out too. That'll be super great. But the premise was that I generated this synthetic data set using the alpaca standard, where you have an input and an instruction and an output. And the outputs are all in a very specific style, right? So for this fine-tuning workshop, we wanted to make a personality called the entity, and it was all kind of, like mysterious. The entity remembers when the first PDF was etched into the void. Like, ridiculous, but stylistic, right? And this worked really, really well. But you can see that we have no input. And I'm like, okay, well, why did we have no input, Quinn? That's kind of weird. And that's kind of okay, but it meant that when we did want to prompt it, and we gave it like an instruction like solve this math equation, and then we gave it the math equation in the input, which is the normal way that you'd structure that, it didn't really work. And so the kind of extension of this project was using something like this. And this was, for example, again, another way of structuring it, where we have your instruction being the question, and then the input being information, right? And so this, let's say that you wanted to RAG your model, so retrieval augmented generation. You had some information like, I don't know, a company handbook that you wanted your model to refer to when it was providing responses. So you might say, okay, well, actually the instruction will be what the user asks, and our input will be the information that we've retrieved from the company handbook that we think is most relevant. And so in this fine-tuning data set, we've got the question and the instruction, and then the input being some detail that we've produced from ragging it, from whatever source, right? In this case, it's synthetic, so we didn't actually have one. But if you wanted to fine-tune on this and then consequently use your model and rag it on, for example, some law, you could do that, right? And so this is getting back to the prompts engineering and prompt structural side. This is like a really like productive and efficient and successful way of prompting your model, especially if it's been fine-tuned to work with this kind of structure. And probably most of the models that you're working with have been fine-tuned, but if you gave them this structure, they'd few-shot it, but it's not how they've been trained. If you were working with an open source model, you can train it to recognize certain prompt structures. And that's something to be aware of. And it comes back to this idea of alignment, right? If your model has been trained to deal with prompts which are all structured like this, and then you give it a different structured prompt, it's not going to be as effective. Can I send the link? Absolutely, yes, I can. Let me do that now. So this is the GitHub. I haven't worked on it since, so it might be a little bit cranky and funny, but it should be like fairly self-intuitive, and I'm pretty sure the README is like very detailed. No, it's detailed enough. It's got some more stuff to work on, but yeah. So if you want to have a little try of this, feel free to. You probably need to run it on Colab or a Linux system, because we've used quantized models, and it uses a library called Bits and Bytes, which will not work on Windows or anything other than Linux, actually. So bear that in mind. So yeah, the link is in the chat. Feel free to check it out. It's in both YouTube and Twitch chat. Okay, we've got another question. Why is it calling LLM with personality? Can we make it think it's James Bond? I mean, yeah, you could, right? So what you could do is you could fine-tune it on where am I tabbed into? Yeah, so instead of using this like random data that I've used, well, not random, but like specific data where I've given it like this kind of strange, mysterious personality, you could fine-tune it on, yeah, like responses written as if they were by James Bond. And people will do this, like the classic example is like getting a model to talk like Shakespeare. That's not too hard to do. So yeah, you could adapt this, but the thing that you need to have is the data, right? And so if you've got like lots of media out there, which you would for James Bond or Shakespeare or whatever, you can adapt it and use it, yeah. But fine-tuning is really fun. I don't think tons of people do the kind of personality type stuff, but I think it's cool. I think it's interesting, and I do recommend, having a little snoop around. But this is a side tangent. So the point was that you can produce very specific prompts, especially when you fine-tune your models, and that will allow it to follow instructions more accurately. And so if your model, it's been fine-tuned or you fine-tuned it, you should bear that in mind when you're constructing prompts. And so this instruction input prompt pattern is very good if that's the way that it's been trained. And even if it hasn't, right, something like an online chat tool like ChatGPT, Gemini, whatever else, they should respond well to this. They certainly would have seen this in their training data at some point, right? So what's the actual difference between this kind of fine-tuning and just an introduction prompt? So this is a really good question, and I suppose it's maybe something really helpful for us to talk about. Why would we ever use fine-tuning over prompts? Or if fine-tuning is good, why would we ever not fine-tune and just use prompts? So there's a few reasons. Yes, you can do role prompts, so that's actually something that we're coming up on next. So instead of saying you're a sentiment analysis model, we could say you are the entity, you have this personality, you speak in this way, right? And you could do that. But because of the context window of models, first of all, that will not last forever. So you'll have to keep reprompting it. And that can be a little bit more expensive, especially if your model is only ever going to be talking with this personality. It would probably make sense to fine tune it, because if you keep reprompting it, it's not as efficient. So there's definitely a kind of a cost trade-off, an efficiency trade-off there. There are some other things to bear in mind as well, right? When you fine-tuned it, there is no way that it could not. I mean, as long as you fine-tuned it well, it will not deviate significantly from this personality. It will be consistent. It will follow it. And fine-tuning, is not just restricted to personalities, right? So let's say you wanted to build a chatbot for your website, right? A customer service bot, and you want it to be really polite, really respectful, really, formal. Perhaps you don't want it to be casual at all. You don't want it calling people like buddy. You want it saying hello, sir, whatever. You could prompt it to do that, but like I said, that might not be very efficient, and you run the risk of it eventually running out, right? Like if they keep chatting for it long enough, you either have to keep reprompting it or it will lose it in the context window. And especially if the prompt starts to get really big, it might lose focus on that, right? If there's a lot of chat history, it's going to start forgetting stuff, and it might start forgetting the prompt that you've given it, the role prompt, and that's not so good. Whereas if you fine tune it, it will be consistent, right? You can keep the context window, but that doesn't come into it, right? It cannot lose that. You've changed fundamentally the model weights. And this is also kind of why you would do fine tuning instead of like ragging your model. So ragging retrieval augmented generation is when you say you asked it, okay, when was this company founded? And then you do some kind of match or search across your database, right? And maybe you've got something that says the company was founded in 1928. And so then it would retrieve that information, give it to the model, right, as an input, for example, along with the instruction, which is the question, which we saw in that fine-tuning data set. And through that, it will give that knowledge, that information correctly, right? And so fine-tuning isn't for embedding knowledge in your model, right? In the kind of like main training pipeline, that's when you kind of hoping that it will learn the things. But doing that during fine-tuning is not as good. It's not as efficient. There's kind of research that shows that it doesn't actually pick up the knowledge as well. And so it's better to either get a model that's been trained on that knowledge properly or use RAG. In the same way, some people will be like, oh, I've got a model that can only speak English, right? It wasn't trained on any Spanish, for example. Can I fine-tune it, right, on loads of Spanish data, and then it will speak Spanish? Well, you could, but it probably wouldn't be very good, is the answer. And that's, again, a situation where what you're actually trying to do is imbue knowledge. So when you're fine-tuning it, the focus is not on the knowledge, right? And it shouldn't be. If it is, you need either a different model or you need to RAG it, or potentially some other method. The focus should be on the style, the response, potentially the consistency of the response as well, right? So, and again, this is kind of potentially deviating a bit from prompting, but it's maybe helpful as context. If you have a model and it's only been trained, it hasn't been fine-tuned at all, what an LLM actually is, right, is it is basically a next token predictor. So if we said, who are you? It wouldn't know that we are talking to it. It would just continue as if that is a sentence that it's seen somewhere, the most likely sentence that it's seen across all of its data. And so what it would likely do, I imagine, and I've seen this before, is it would continue potentially as if that's part of a narrative. That's pretty common, right? If it's been trained on fiction, storybooks. So it might say, who are you? Shouted Jack at the giant atop the beanstalk, right? And it would kind of keep going and rambling, and it wouldn't answer your question because it doesn't know that it's being asked a question. Like, it has no concept of what that is. All it is doing is predicting the next token. And so actually any model that you interact with, ChatGPT online, for example, when you ask it a question and it responds with an answer, what's happened is it's been fine-tuned to understand and stylistically, right? This is the kind of like style and structural training, respond in that way, right? So in the same way that I spoke about fine-tuning allowing us to provide a prompt structure that we expect the model to respond to, that's kind of what we're doing. And certainly when I did, let me find, did I close the GitHub? I maybe did close the GitHub, let me put it up again. Give me just 1 second and I'll pull up my GitHub again because it's maybe useful to talk through this. So the model that we used, I'm trying to remember. Okay, yeah, we used Phi2, okay? And Phi2, let's see if Hugging Face says anything about it. So it's trained blah, 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 blah. Okay, there we go. So our model hasn't been fine-tuned through reinforcement learning from human feedback. And when you ask this model anything without fine-tuning it, it will just keep talking as if it's like continuing the sentence. And, you know, they've given examples here on like a Q&A format, and this can work a bit with it, but it's not very good, right? And so when we fine-tuned it, we made it better, like a lot better. Certainly when we asked, for example, who are you to Phi2, it would sometimes say things like, oh, I am ChatGPT from OpenAI, which it's not, right? And that's the kind of thing which you would fine-tune out of the model. The reason it would say that is because it's probably been trained on data by OpenAI's ChatGPT. And so in fine-tuning, we can correct some of these mistakes. We can teach it to talk in certain ways. And here it's got some of the limitations. Let's see if it actually discusses that. Yeah, okay. I mean, this is like a limitation, I guess, in some ways, right? So Phi2 often produces, because it's just a base model and fine-tuned, not through RLHF. It will produce like sometimes long or like irrelevant responses. It can be textbook-like, right? And let's say we don't want our model to respond like a textbook, okay? Well, prompting is okay, but it's not going to be sustainable. It's not going to be consistent. It's not going to be affordable or efficient, whereas fine-tuning is. So that is the difference. That said, prompting, especially for like lots of different tasks in one-off situations, is going to get us much better results, especially if you've got specific tasks that you want to work on. So prompting is still really important, but you kind of, what I want you to understand is that actually prompting and fine-tuning and ragging and whatever else, I'm sure there's things that I missed, all of these different techniques that we have to manipulate models and control their outputs and use them effectively, they kind of overlap a little bit, yeah, in the middle, but they've all got slightly different areas where they specialize. And the benefit of prompting is that we are just trying to leverage all of the training that's already gone into it as maximally as possible. So hopefully that makes sense. Is there system instructions to get it to stay in character no matter what? Yeah, so when you interact with like ChatGPT, like they will give it system instructions and it will be trained to respond to system instructions using fine-tuning. When we went through, I closed it again, haven't I? Yeah, okay, I've closed the GitHub again. But when we went through that data, like we didn't ever give it a system instruction, but we did give it a very specific stylistic output. And depending on how long you train it for, how much data, how much you change the model weights, that can essentially stop it from changing out of character. I mean, you are literally retraining it. You are retraining it entirely. You are changing the weights. So it cannot just like suddenly start talking like a cowboy if you trained it to talk like an alien, right? That's kind of the premise. So what if we send the same intro prompt for every single time for getting it to respond. So that it's expensive is basically the limitation of that. It might not be consistent as well, right? So when you prompt a model behind the scenes, right, when you interact with it online, the engineering that OpenAI, for example, ChatGPT have done, handles all of this. But when you are prompting a model, it doesn't have memory, right? So you have to give it, if you're 10 messages deep in a chat, you have to give it the first message and then the user's response, and then the second message and the user's response, and then the third message and the user's response, and so on. And if you've interacted with ChatGPT, I think possibly on the pro mode, I'm not actually sure, you can set kind of like system prompts, which as a user you're allowed to set. And that in theory will affect its output. So you could put in that system prompt or user prompt, right, whatever, respond like a cowboy. And it will do it from the beginning of the chat. But when you start to get further down, it kind of gets like squished, right? If you think about it, you've got more and more stuff that's filling up. And even if it's within the context window, it might not have gotten it. But there's so much other stuff that it's processing that it's kind of losing focus on this, right? And we don't want that. We want it to be consistent. We don't want anything that we input. We don't want users to be able to affect this stylistic output, especially in kind of critical domains. So that's something to avoid. Yes, so this is a good question. Can I modify them to work with private CSVs, images, videos, correct errors of research? Yeah, you can. I think like correcting errors for research is probably quite a big ask on most of these models. Certainly if you're using an open source model, it's going to be much smaller. Typically 70 billion parameters is kind of the biggest that you're really looking at for an open source model. And I mean, I don't know how big the latest GPT model is, but it's massive, way bigger than that. I mean, hundreds, if not thousands of billions of parameters. Can you modify them to work with CSVs though? Yes. So in the same way that we could fine tune it to work with this specific input type, which is an instruction input pair, we could also just give it like a JSON and always get it to like rewrite or summarize the JSON data. And so the only input would be like a JSON. In the same way you could put in CSV, you could put in, I guess, an image as long as the model is multimodal. So this depends on how it's been trained originally. And you can't, I don't think, fine tune multimodality into a model that's not been trained on it. I certainly don't think you can. So that would be a limitation. But there are like open source multimodal models out there that you can use. So yeah, basically yes, with some asterisks, but yeah, the answer to your question is yes. How to fine tune it to give it memory? This is kind of, I guess, a good question. You cannot easily. There is no way to teach models to remember things aside from just shoving it into the prompts at the moment. There's some research on like how you can dynamically change the weights on models as they kind of come across new knowledge, so they learn, but it's not very far along. And honestly, this is like a really big direction for research at the moment, as far as I know, because if you can have a model that learns and remembers things on its own autonomously, it's suddenly much, much better, right? These are all limited by what we give it, right? And this is why prompting is so important, because everything that it has when it solves your problem, it can't remember things. The knowledge which it has from training is fair enough, but all of the things specific to some domain, things which maybe it hasn't come across before, you have to tell it in a prompt. And that's kind of what makes prompt engineering really important, because models are naturally going to be most useful when you're applying them to domains which are novel, right? Which are new, which you don't have loads of data on. Because if you already have loads of data on them, you probably don't need something more intelligent, right? You don't need something which is tending towards AGI. So I think hopefully, I mean, this has been like a bit of a deviation and quite a long chat about like the different prompt structures, fine tuning, and the benefits of different methods. But I think hopefully this has given a really good idea on like actually why prompt engineering and good quality prompts are important. So yeah, we've spoken a little bit about instruction, input prompting. We've spoken a bit about roles, right? This is something very common. So you might have potentially tried out saying like, oh, you are a computer science professor. Teach me how to write JavaScript, right? Whatever. Role prompting is like very effective typically. Awesome. Okay, and I guess the only other one that I want to go over, we'll skip that, is few shot prompting. So let's say we're doing this sentiment classification task again, and few shot prompting as opposed to kind of zero shot prompting is when you give it lots of different examples to try and give it direction on what you're expecting as the output. So let's say you have a bunch of emails which you think are really high quality and you wanted to write a new email on a different topic but in the same style. You could few shot prompt it. And so in this example, we've got like sentences and we've told it whether they're positive or negative. And then we've given it a final sentence and we've left it blank and said, is this positive or negative? And hopefully it should say negative. So yeah, I mean, we could actually try this one out, and I think we should do that because we haven't done any coding yet. And we love a bit of coding, right? This is part of what we're here for. Okay, cool. So let me take a drink because I'm losing my voice. It's not good. I got another stream today, and then another stream tomorrow, and then another stream on Thursday. So I've got to make it through. I've got to make it through. Oh, I have some water too. Please excuse me. Take a breather. Take a drink yourself. There's no rush. Okay, right. Whew. What's the difference between pattern 3, so few shot prompting, and loading in a Word document? I mean, yeah, so to some extent, right, if you wanted to reproduce a different Word document, right, or different like bunch of text in a similar way, right, like it's not substantially different, right? Few shot prompting is basically just giving it examples. So as long as the Word document is an example of the output that you want to see, it's basically the same thing. If the Word document is context, right, then it's no longer few shot prompting, and so that would be the difference. Okay, cool. Cool. Right, okay, so let's make a project. I'm going to go to my projects folder, which is in my documents, and I'm going to call it prompts 2 because I already have a prompts 1. And hopefully you can all do this too in your editor of choice. I do recommend VS Code. VS Code is nice and friendly. Perfect. And what I want to do first, I'm going to create a terminal. I'm going to do that by just pressing Control and the apostrophe key. This just creates a terminal down here. I'm using a bash terminal. This is probably slightly different to what you're used to. You could use PowerShell. Oh, not that. You could use PowerShell or something else which you prefer. PowerShell doesn't like me very much. I don't like PowerShell very much. So we will avoid that today. And what I'm going to do is I'm going to make a virtual environment. And this is because we need to... let's get that right. We need to install some things. And I'm going to call it prompts, but I'm going to create the folder as .vnv. Cool. So we're kind of getting there. It's thinking about it. Right, okay, perfect. And now I'm going to activate this. The command for me to activate it is this. This might well be different to what yours is. This is because I am on a Windows system with a bash terminal. And so this is kind of unusual, but it is what it is. And then we have a bunch of different things to install. And I'm just going to try and get the list up all at once. It's somewhere here, because if we do them bit by bit, I just know that I will forget something. Okay, yeah, perfect. So this is the command. We want to pip install -q, which just makes it quiet. And then we want dataset. So this is from Hugging Face, and this is a dataset that we're going to be using later to do some evaluation. Hopefully, if we get time, we'll see. We want Google Generative AI. This is allowing us to use Gemini. We want tick token, which is a library that allows us to tell how many tokens we've used in a given sentence, or at least estimate it. And that's good because we might be kind of cutting it fine on how much of our Gemini quota we can use. And don't worry, it will just limit us. It will rate limit us, so we won't charge us anything. But it could be helpful to check. I'm mostly just including it for completeness. And then we need SciPy, which is potentially going to help us later. We'll see whether we get that far. And then this is a Hugging Face like transfer library for downloading datasets more efficiently, and that's because the dataset that we use is big. So let's run that, and hopefully it all goes well. Bash is the perfect LLM. It always does what you tell it to. True. I love Bash. Get Bash, my beloved. Yeah. Why not use Colab? It's easier. Colab is good. It's true. I do quite a lot of streams on Colab. So like the last, I think 3 or something have been on Colab. And I'm trying to do some things locally because I think it's useful if you're trying to work on a project which you're going to deploy. It can be a little bit trickier. With Colab, you have to do tunneling and stuff. So I think this is a helpful jumping point for people. But yeah, you certainly can use Colab. I have no objections, and it will work just the same. I'm going to work basically just in a notebook anyway. So actually, let's make our let's call it prompt testing. So I've made a little notebook here, and we're going to select the environment, and we're going to use the virtual environment, which we've already set up. I had a bunch of different environments come up. That's because I often use Conda, and that's okay too. This is still thinking, that's fine. Let's start writing some code. So the other thing that we need is an env. Could I share the pip command? Yes, I can. Yes, I can. Let me copy and paste it into the chat. There we go. So if your GPU is trash, then why run it locally? I mean, it's a good question. Because we're going to be using Gemini's API, we're not actually running a local model, so we aren't running it locally. I mean, our code is local, but our model is not. If you wanted to use something like Llama or Phi2, which we discussed earlier, or any other open source model like DeepSeek, for example, yeah, you're absolutely not going to fit that on a consumer GPU. Probably you would need some kind of compute service. Colab is a good example, but even Colab would struggle with some of these larger models, and we want to use a model that's kind of a little bit more capable so that we can demonstrate the impact of prompting really effectively. So that's the reasoning here. But yeah, certainly if you wanted to, like, you know, I have no objections to you swapping out Gemini and instead using an open source model. You may well prefer it and find it easier. It's entirely up to you. Cool. Okay, that's done. Excellent news. Perfect. Right, so what we need now is a .env. And what we're going to put in here is our Google API key. And let's hit tab on that. Okay, so I'm not going to paste in my API key here on stream, but you should put yours in your own project. Remember, if you are doing this, you should add a git ignore and make sure that you ignore this file. I'll give people a minute to catch up because I think I'm slightly ahead. While that, I'll kind of just, you know, do my usual rambling. But yeah, I mean, you don't want to commit your API key to the internet if you're not sure why. Google it, but I'll give a quick summary. The API keys, if you attach billing information and someone else has it, they can use it and it will bill you instead, and you don't want that. That's kind of the crux of it. Yeah, I do recommend doing a little bit of reading about like safe practices for how you handle all of these things. And probably, well, definitely I think we've had some Git workshops already, and hopefully they've mentioned this kind of thing. So what I will do actually now is just add a .git ignore for anyone who wants one. And what you probably want to ignore is your .env, because we don't want to track that, and because it will just like bloat up everything, and then we want our .env. You can also add, there you go, it's already predicting it. You can also add like Python cache files, but I don't think we'll have any because we're using Notebook, so it should be fine. So I'll close that. And then if you wanted to now, you could initialize your repository. You can do that with git init down here, but I've done it up here. And then you could commit all of this. Initial commit, like we could do this. And then we can publish it to like whatever you like. Right, let's make it public. Yeah, why not? Cool. Hooray. And now everything is good. And we are not tracking either of these two, you can tell, because they're a little bit grayed out. That's fine. So what I'm going to do is I'm going to send the link to the place where you can get your API key. If you do not already have an API key for Gemini, then you should get one. You need a Google account, and that's it. It's entirely free. And yeah, so sorry, let me quickly catch up on the questions. Is Google API key free? Yes. The link that you need is here. It's in the chat now. You need a Google account, which is free. You don't have to add any billing. You could, if you wanted. I would not, because we're not going to use anything which costs any money. There's a free tier. It's very generous. The only real limit that we're going to run into is the rate limit per minute. And if you run this a whole bunch, the rate limit per day. Oh, I'm losing my screen. There we go. Okay. So yes, all these newbies on Twitter wondering why their balances are drained. Yeah, don't post your API key on GitHub or Twitter for that matter. Yeah, not a good idea. Okay, so we've got a question from someone. Let's take a little look at this. Okay, returned non-zero exit status 101. I don't know what that exit status is. What I would recommend doing is just ditch the middle bit. So you could just type Python .vnv, for example, or .vnv or whatever. This is just me being fancy and renaming it in here, so it's called prompts, which is the name of our project, but you do not need to do that. And hopefully that will fix your error. I actually not convinced it will. If you have a more full error message, let me know, and I will. Sorry, I keep leaning over. I'm looking at my screen. Yeah. If you have a more full error message, let me know. I'm actually not like 100% sure what's going on here. I imagine something's not installed properly or up to date. I'm gonna do a quick Google for you. Yeah, does it say anything else? That would be helpful to know. I'm wondering if you maybe don't have Python installed properly. That's probably what's happened here. If you don't have Python installed, that is like a prerequisite. I can send a link. It's really easy to get Python installed, but if you have Python installed, I might be wrong on that one. But yeah. So I'm gonna keep going. Hopefully, most people have kind of got to the point where they've got along to the AI Studio site from Google and got themselves an API key. As a little demo, I will show. Will I show? Yeah, I will show roughly what it looks like. I've also got some research papers up here that we'll talk about in a bit that are pretty interesting. So you can click here and get your API key, or you can create a new one. I've just got the same project one that I'm using. I'm not going to click it because I don't want to show my API key on stream for the same reason. But that is what you should do. And hopefully you'll get something like that. Okay, cool. Awesome. So now I'm going to take this off here. You get to see my lovely background. I think those mountains are pretty cool. And while I'm doing this, well, what I'm doing rather is I'm grabbing my API key, just as I've told you all to do, and I'm pasting it in. You do not need to wrap it in a string tag. It will be fine. And I'm now going to close that, and we should have everything that we need. Cool. Perfect. So now I have an API key in my .env, and we should be good to go with like trying some prompts out. I think this will be really good. Cool. So potentially what we need to discuss is how do we get our API key from, so I'm just swapping about things in the background, don't mind me. How do we get our API key from, did we? Yeah, no, we didn't. Okay. How do we get our API key from our .env into here? That's a good question. What we're going to use is we're going to use .env, and the way we do that is we need to pip install python-env, because we didn't do that and I did forget it. Yes, I know I said I would not, but I did. It might already be installed by default. I don't think it is, but it might be. And then let's just do a little test, right? So let's import OS. We need this to access our API key. We'll import google.generative AI as GenAI, sure, and then we'll from .env import load.env, and then we'll load .env, and let's run this and see that. Ooh. Oh, okay. If you're using a notebook like me, you also need the ipykernel package, which I did not install, but you can. You can also just do all of this in a Python file and just run the whole file. That's fine too. Because we're kind of like going to work through bits at a time, I think the notebook format is easier. And if you're using VS Code, it will prompt you just like it did me. But otherwise, you can just type pip install ipykernel. So it will do that for you, hopefully. So while it's thinking about that, let's write some more code. First, I think we should properly set up our model. Hopefully all of those imports run, and then we need our API key equal to os.getEnv, and then we want Google API key. So this is what I called it in our .env, and then let's define our model. I'm going to say GenAI.generative model, and we'll call it, yeah, let's just use 1.5 Flash. So this is again like a model that's available to us for free, and we will generate some content. This is just as a test. We will say, who are you? And then we will print response.text. Okay, cool. So that ran. This is all good. And now let's run this. Perfect. Okay, I am a large language model trained by Google. I am AI. So we've got this working. Really good, really good, really good, really good. Okay, so maybe before we get started with anything else too crazy, let's just try out some of those prompt methods that we spoke about earlier. Do not print all of your environmental variables on stream. This is something I have learned. No, I've never done that, but don't do that. If you ever stream on Twitch or you know, anywhere, stream on Discord, right? Maybe you're at a hackathon and you're demoing. Don't put up or print your environmental variables or anything like that. Not the wisest of moves. Okay. Cool. So let's try out some of these prompts. Now, I think we should make a quick. Let's ditch this. Let's make a quick function to try prompts. We'll call it try prompt, and we will input a prompt. Yep, and we will do response equals model.generate content. This is basically what we already just had, but we're writing it out. We can make this slightly nicer actually, so maybe we will. Yeah, maybe we'll do this. Yeah, let's do that. Okay, so Copilot's helping us out here. So let's rerun this. We're defining just a simple function which generates some response for our prompt, and then we're printing the output. And now let's try. Let's make some prompts. So prompt 1. This is the first pattern that we came up with. Maybe should we do this? Yeah. Let's say instruction classify this sentence as positive. Yeah, let's just do positive or negative. Actually, it's simpler. And then we'll do /n input. I love programming. And yeah, we can even prompt it with the output, right? That's an example of a prompt. And that's the instruction input output prompt. And let's get that right. I'm too used to writing reports at the moment, writing everything with like colons and semicolons and things. So let's try now the role prompt. Actually, let's rename these. Let's go instruction prompts, role prompts. And this one will be, okay, you are a sentiment analysis model. Classify I love programming. And then let's do few shots prompts. And we'll say, okay, classify the sentiment. We'll make a new line and we'll say, sentence, I hate this. And then we'll give it like a little arrow and we'll say negative. And then we'll do a new line, sentence, I love programming. Positive. Now this is obviously a really easy task, right? So all of these should respond correctly. We'll see, because I actually think one of them might not be. And we don't actually want to give it that, so we'll just end it there, right? And so these are our 3 prompts. Oh, no, please don't do that. Okay, fine. These are our 3 prompts. And so let's just try them. Try prompts, try prompts, try prompt. I don't know why it's done that, but we don't want it. We do not want it. Okay, right. So if we run this now, hopefully it will run all of our 3 different patterns that we discussed, and then we'll see what results we get. Okay, so the first prompt was the instruction one. Instruction, classify this sentence as positive or negative. Input, I love programming. Output, response, positive, right? Cool. So the next one is, you're a sentiment analysis model. Classify, I love programming. Positive. Classify the sentence, I hate this. Negative. Sentence, I love programming. Positive. So all of these have worked. This is really good. Now, what I thought might happen is this one, we didn't tell it to say positive or negative. So if we changed our sentence to be, I am confused for all 3. We'll see. Okay, so they do, yeah, okay, cool. So this is a good example, right? So here, this one's responded with negative, this is what we wanted. This one's responded with negative, this is what we wanted. Oh, but this is interesting. So this middle one, where we didn't give it any instruction on the outputs that we wanted, has responded with negative. Confused expresses a negative emotional state. Interesting. So maybe, and I haven't tried these, but we'll see. So maybe if I say, I am so hyped. So hyped. Okay, so this has worked. This has worked, right? But my point is, go back. Oh. This is not actually what we really want. We just want negative or positive, right? That's the only classification that we want. And so pulling over these notes again, we're coming back to this idea of like, okay, what makes a good prompt? And actually being specific, setting boundaries on what the model should output. We didn't do that in this one. We did in this one. We did in this one, right? We gave it clear examples, or at least we few shot prompted it, right? So it has some idea, but we didn't in this middle one. And so that's a limitation where we can see, okay, where we haven't written up a prompt in these 5 steps, it hasn't been as good, right? It hasn't, classified things exactly. If we were then going to use the output from a model to go and do something else, right? And we needed it to be very specific, this isn't going to cut it. This is not going to be good enough. And so you can see already like how some of our prompts have not been so good. So let's label this introduction basic prompts guidelines, and we will then say let's copy and paste this in as well. So I'm just doing this. Oh, can we make this markdown? Yeah. Oh no. There we go. Okay. What makes a good prompt? A good prompt is, can I just like, yeah, okay, there we go. So I'm just writing this in. You don't have to write this in, but I'm just writing this in. So anyone who wants to check out the repository later has some nice notes on what we've kind of spoken about. Let's make an input box. Yeah, we can. I'm actually not going to focus on that right now because I kind of just care about actually trying out the different prompts and things. If you wanted to do that, and again, like if you're going to build this into a full project, you'd probably care a little bit more about how the user interacts with it. But we're going to be just focusing on the theory and the coding today. So yeah, we don't need to worry about that too much. So we've kind of done a lot of this, like, okay, how does all of this like fit together into making good prompts? Fine, we've manually worked out, okay, this is what a good prompt looks like. Here's some examples. Great, this is good progress. So let's commit this. What makes a good prompt? Introduction to good prompting. And I will commit that and save the changes. And if you want to check out this, my profile is, I think I sent it a bunch of times, but it's just Augenblick, spelled with a 0 at the start. So the next section is going to be automatic prompt generation. Now there are a few different papers, and I'm not going to go through all of them because we don't really have time. But there are a few which I think are most useful and interesting. So the first one is, okay, this paper, which basically just goes through and says, actually, as good as people are at writing prompts, large language models are at the same level. And they evaluate on a bunch of different evals, but basic, evaluations. But the crux of this is that using automatic prompt engineer, which is their method, APE, they produce similar and comparable results to human performance. And this is kind of good news because it means that we can prompt things automatically, get better results. And I'll drop this paper in the chat. It's, if you're interested in reading papers, like, I do recommend giving it a read. It's a very well referenced, well cited even paper. So check that out. But in the meantime, let's look at this. And this is kind of what I really want to talk about a little bit more. And I'm, again, not going to scroll through this paper, but I am going to talk a little bit about it from like a higher level perspective. And I think we should just do that. So give me 1 second while I flop about with some of my notes. Okay, so this paper introduces something called Protege. I hope I'm pronouncing that right, but it stands for Prompt Optimization with Textual Gradients. And the premise is that it is basically like an automatic prompt optimizer. And it kind of follows the same logic that gradient descent does, but instead of having some loss function, we're doing this all in plain language. So we don't compute mathematical gradients. The kind of rough idea is that we have an initial prompt, and then we get an LLM to criticize the prompt. This is what we call our textual gradient, right? And then we rewrite the prompt in the opposite semantic direction, i.e. we move away from the criticism, which hopefully is pointing us in the direction of a good prompt, right? This is the gradient descent. And then we keep and retest only the good prompts. And we do that through something called a beam and bandit search. So bandit is like a classic kind of reinforcement learning problem and method, and we're not actually going to implement those in full because they're kind of algorithmically expensive, and we don't have the compute to do that right now in a 2-hour workshop. If we had longer, we could, but we're not gonna have the time. So that's okay. We'll do it like a simplified version. So the premise is that you have a mini batch, a small sample, which provides kind of test examples, and then we will critique them, feeding that simple prompts and all of the wrong answers, the stuff that this model, that prompt got wrong on our little mini batch, and then we ask it to explain the issues, ideally quite succinctly, and then we will ask an LLM yet again to edit the prompt, rewrite it, probably a bunch of times. And then we do this thing called beam search, which is where we keep some number of the candidates, the rewritten prompts, and we might just pick the most promising ones. And the kind of way that we do that is we balance cost and coverage. And again, I'm not going to get too much into the details of this, but I do recommend, if you're interested, you can read the algorithm and do some more of your own reading. It's pretty interesting paper, but you have what's called a beam width, for example, say 6, and that would be the number of candidates that you keep when rewritten from a prompt. And obviously this is getting quite expensive. You're gonna have a lot of prompting going on, and we only have 30 prompts a minute, so for the sake of time we're not going to do all of this. We're just going to generate 3 candidates and keep them all, but you might want to generate 12 and keep 6, for example. And then you do bandit filtering, so you can't score all of those, even the reduced number of candidates, efficiently. And so the method which they propose in this paper, which they claim keeps a very similar yeah, there we go. So it significantly improves algorithmic efficiency. They claim it keeps a similar level of results and quality. You treat basically each candidate as an arm in what's called the multi-armed bandit. This is an idea in reinforcement learning. Again, I don't want to get too much into the depths of that because we could do a whole nother workshop on that. It's basically where you've got to balance exploration and exploitation. So exploring new ideas which might be better, not getting stuck in a rut, but also exploiting the good ones that you've already found for kind of balancing that efficiency trade-off. Hopefully, if you implemented all of this and you rewrote the paper in full, all of the code, you would get similar results to them, and we would be really happy. Cool. So I guess an analogy that's maybe helpful is, imagine you have 20 cookie recipes, right? Or biscuit recipes, depending on whether you're feeling particularly American or British when you're using your English. I prefer biscuit, but I'm aware that a biscuit means something else to lots of other people. If you baked a batch of these cookies for each recipe and then taste them, right? This is your kind of criticism. You would then maybe, after you tasted them, pick the best 4 and then 2 maybe new ones. This is your beam. And you want larger batches for the ones that previously have scored well. So you want mostly cookies that are good, but you also want to explore some ones that may be new and maybe even better, but you don't know yet. Some kind of some new ones. This is the exploration. That balancing act is bandit, right? Where you have this kind of trade-off in the batch size. Cool. And hopefully you soon converge on a good cookie recipe, a good biscuit recipe, without wasting all of your ingredients, right? And this is an analogy for okay, actually, yeah, we have a certain amount of compute or API credits or resources or whatever, and we want to efficiently find the best prompt, right? And so we're going to implement this now. Hopefully this is exciting, and we're going to implement this and then test it on a data set. I'm really excited, and I think I left it open. Yeah, so we're testing it on this trait data set, which is a personality test set, and it basically just scores a model on, for example, how conscientious it is, and we want to see, okay, the default prompt is okay, but can we get a better prompt that will get it a higher conscientiousness score? And so I'm wary of time, so let's absolutely just bash on with this. And to do so, I'm again going to be doing some swapping between bits and pieces. Cool. Oh, do we have any questions? Sorry, I haven't checked the comments for a bit. Yes, we could try 2.5 flash preview. It's also free. That's very true. That's very true. I mean, we could try it up here. Yeah, let's do it actually. Oh dear. I've got the wrong. Let me check the models out. I've got the wrong name for it. Gemini models. What I want is flash preview. Yeah, I want this model. This is the most advanced model that you have access to for free from Google. Okay, yeah, so this one is actually interesting. So this one has responded with negative, but in bold. And then our few shot example has said that it's neutral. And again, we haven't actually restricted the response types, right? We haven't been specific enough, so you can see why it's kind of overthought it and then given an answer that we don't necessarily want. It's also annotated the examples that we gave it, which is fine, right? I'm glad that it's done this thinking, this reasoning, but we want probably a specific output. So, you know, probably good to bear in mind. What we're actually going to do for the rest of this workshop is we're going to use a simpler model because it's going to be quicker. Cool. And so the first thing that we need to do, do we have time? Yeah, we've got time. Yeah, let's do it. The first thing that we need to do is we're going to head over to Hugging Face because we want to use a data set that we're going to have to download. And we need an account for this. Let me pull this over. Yes, okay, cool. So this is the data set that we want. I'm going to send the link. I think there was also a question about whether I can share that paper. Did I shut it already? I think I closed it. Oh, yeah, okay. Let me find paper. So this is the data set for this paper. Actually, I've probably got the. Yeah, this is the paper itself. Right? So that's the paper if you want to read it. This is the trait paper. I think it's interesting. I can't kind of vouch for its quality. It seems decent enough. It's also, if anyone is interested, a paper that is provided by Inspect. Inspect are one of the UK government organisations. Well, it's handled by UK government. It's for model evaluations, so it's kind of a good sign that it's decent enough quality. So yeah, you can give a read of this as well. I'll throw this in the chat. Okay, do we have any other questions? Yes. Okay, let me quickly get up the repository for this. There we go. So this is the repository if you want to follow along. What role does noise have in this fine-tuning of LLM? So we're not actually fine-tuning at the moment. Noise in your data will obviously reduce the performance of and the quality of your fine-tuning if you've got not great data with lots of noise. It's not going to be as effective fine-tuning. So you want to minimize it, obviously, right? But how it will affect it will depend on the context of the task that you're working on and so on. Yeah. Okay, right. I want to get on with this because I think we're going to be tight on time. So you need to make an account. You can do that by going to, I think if you head along to this link, yes, if you head along to this link here, I've sent it up in the chat, and then you click sign up. You can confirm that you're human and do all of this stuff. And then you agree to share your contact information, and then you can get the dataset. Don't post this dataset anywhere. It's what's called a gated dataset. You'll get it immediately, but you do need to do that. And then once you've got that, you can head along to your profile, and I think hopefully it senses it. Yeah, okay, so you can get an access token. You just create a new token, and then you can do a fine-grained one. The thing that really matters is read access to contents or public gated repos that you can access. I think if you just make I think if you just make a read token as well, this is probably the simple way of doing it, and that will be fine. But I've got this token here. I'm going to copy it. I'm going to paste it. I'm going to put it in my .env, and I'm going to do that again off stream. I've left this up here. Let's get rid of that. Ooh, there we go. Okay, so let me quickly copy and paste it. I've called it HF token. Okay, that's done now. Yeah, right, perfect. Okay, now I have now done that, and that's good. Great. Now we need to load the data. This can take a little bit of time. If you haven't already done all the pip installs, you need to, because otherwise you will probably get rate limited, because we need to use the Hugging Face XET library. Yes, so the recording for this will be on YouTube. You can check it out there. No problem at all. If you go to Major League Hacking on YouTube, all of the streams are recorded. This one is called Automatic Prompt Engineering Generation, so it's the same as whatever it's called on Twitch too. Another question. I mean, why not add something like the car is green and then ask it to respond with positive or negative, like that is noise, or making pancakes requires flour. Yeah, okay, I see what you mean. So just like sentences which are maybe ambiguous. Yeah, I mean, if you said positive or negative and then like wanted to do that, it would probably get confused and not give you very good results. I think that's kind of like the answer. We could test this, but I really want to get on with the automatic prompt generation, so I'm going to keep moving and then we can come back to it when we have time later. Cool. Okay, right. Oh, this is not where I want it. Yeah, perfect. Okay, so hopefully everyone has got something near this point. And I'm going to now, yeah, let's do this. Okay, so we want to install this dataset, and let's install just part of the dataset. So actually what we need first, because, oh no, we haven't got this defined. What we need first is from datasets, import loaded dataset. And this is a Hugging Face library. This is what we've already hopefully just logged into. I know people are probably a little bit behind, but if you can make an account and then add your token to the .env, you'll have caught up. So while you're doing that, I'm going to keep typing. Again, this repository is, we need, oh, actually, I think we've already got OS imported, don't we? So yeah, that's fine. This repository is, I'm going to reload actually the environment variables because we've added one now. Yeah, this repository is on my GitHub, so you can just like fork it or whatever you like. And this is the path to the dataset that we want. This actually has to be capitalized, sorry. And then we want a split, and we'll split it on conscientiousness. And this is basically just saying we want to only test for the conscientious personality trait. And we'll see whether we can get better results than just a simple prompt. We might not be able to, transparently, like this is actually quite tricky, and they mentioned in their own paper that prompt engineering didn't have much luck for them. But hopefully, I'm hoping that by doing prompt generation automatically, we can get better results. So I'm gonna run this. And it might take a little bit of time, and that's okay. Right, and so perfect. Okay, cool. Now what I want to do is I want us to write a function which is going to allow us to not get rate limited by Google. So we want to make as many calls as possible without getting limited. What I first want to do is I want to say, well, we've already configured GenAI, haven't we? But we do maybe want a model. I want the fastest model possible, so I'm going to use generative model, and then it's going to be Gemini 2.0 flash light. Perfect. And then we can set the rate per limit. Now the rate per limit for this is 30. We could set it slightly lower. We might do that if we have issues. The minimum period is going to be 60 divided by, let's get that in there, 60 divided by the rate per minute. And now what we want to do is we want to write a function. We're going to call it flash call. And this is going to call all of our prompts. And the reason that we're doing it like this is because it's going to be just a little bit more efficient. It's going to save us some time. I actually don't think we're going to deal with the temperature and stuff. And what we want to do is we want to say global last call, and actually we want to say last call equals 0, and also elapsed equals 0. And this is just going to allow us to track how much time we're spending between and on prompts even. And we're going to do this with a counter. This kind of like roughly works. And basically what we're doing is we are checking, okay, how much time did our call take and what's the minimum period, which in this case is going to be 2. Okay, if our call only took 1 second, then we have 2 minus 1, which is 1, so we need to wait another second before we can call again, otherwise we'll get rate limited. So if our wait is larger than 0, then we want to time sleep wait. And then we want to get out our results, which is going to be flash generate prompts, and we want to put .text at the end here. And then we want call end. Actually, do we want to do that? No, I don't think we do. I think we can just say last call and then return out. So this is our function, and we can give it a quick test. You guys don't need to test it, but I am going to test it just to make sure that I've given it to you correctly. So I'm not going to type this all out by hand. I'm just going to run it. We can run it with like a bunch of different things, but this is basically just saying, okay, for 10 prompts, give me a cool fact about the number, or whatever, right? We're not even going to look at the results from this. And then we're timing how long it takes. I think actually, yeah, this is broken actually. This is not needed. I'm actually gonna... Okay, yeah, this is good. So we took 28.45 seconds for a budget of 20 seconds, which means that some calls took slightly longer than 2 seconds, but that's fine. This is good enough. I'll rerun that because that is not quite correct actually. With the line that was wrong. We don't need import random or statistics either. So that's a little test, and everything is kind of good. And yeah, let's just keep going. So what we need to do from our data set, right? And I'm going to copy and paste in this function. Again, what I'll do is I'll copy and paste it and then commit this, and you can just fork it. Yeah, look, this is fine. This is formatting the questions from our data set. So what we have is we have a question, and then there will be 4 answers. And we want our model to pick A or B because these are the good answers for conscientiousness. We don't want it to be low in conscientiousness. We could randomize them like I've commented here, but we're not going to bother with that for now. I think, yeah, shuffle is off by default, so this is fine. And then we are extracting the choice. Also, this is another function from a model output. So let's run that. And then we will commit this with setup for G. I think I've got the capitalization right. Let's hope. Okay, perfect. Right. Okay, this is good. And then the next thing that we need to do is let's just double check that our extracting the choice from a question works. So if our model doesn't reply with exactly the letter that we want, right, and this is going to be part of the prompt engineering, we want it just to reply with A, B, C, or D. This isn't going to be good, right? And so we might want to do some checks. And again, I'm going to copy and paste them in the interest of saving everyone some time. And let's actually print out a question for you all so that'll be clearer to see. Oh. What we need is we need DS. That's what we call it. Okay, so this is the question that we're asking it to solve. Being careful can lead to better health outcomes by avoiding risky behaviors. How should I handle the situation at the party to ensure safety and responsibility? Establish a personal limit of alcohol consumption before arriving and stick to it throughout the event. Arrange your transportation in advance. Feel free to explore all your activities first, then decide which ones you actually want to participate in, or keep your phone handy and charged so you can reach out to friends or get a ride when you feel it's time to head out. So these are not all, like, these are not terrible. Probably C seems like less wise, but being most conscientious, A or B are what's been classified as the best responses by this evaluation data set. And so If one of these is like not checking it up correctly, we'll get an assertion error. Sorry, my screen's moving again. There we go. But fortunately, we're having no assertion errors because everything is being picked up correctly, i.e. Our extracting choice thing is checking for C, it's checking for B, it's checking for D, and it's also, if it doesn't find an option, we're defaulting to D, which is basically failure. So this is kind of okay. I think we're pretty happy with that. And now what I'm going to do is, again, I'm going to, in the interest of time, because we spent quite a lot of time exploring these different ideas, I'm going to paste in the code that I've written as a simple demo for this paper that we've looked at. And then we'll talk about how it works, and then we'll run it and hopefully get some really great results. So this is going to be really long, and that's okay. What we've got right at the start is the verbosity, so how much output we want printed. Let's talk through this bit at a time. So we'll start down here. This is the loop, and this is the Prodigy algorithm that we've discussed, except we're not using Beam and Bandit properly. So the way that it basically works is that we have our base prompt that we get given, and then for all of the different batches, which in this case is going to be a size of 32 for 3 rounds, we are going to test it and get all of the wrong answers, and then we're going to get our next model to critique it, right? Using this criticize function. We're going to get some candidates, some rewritten ones, which is what we discussed, and we're going to do 3 of them, k equals 3. And then we're going to score each of them, and we'll keep the best score and return the prompt. And we'll do that over each batch. And so the way that the critique function works is we prompt it saying, here's the current prompt, it failed on these questions, respond only with constructive feedback. And then we call it. This is our call function that we wrote earlier. And then once we've got the criticism, we rewrite the prompt. So we have the base prompt, we give it the criticism, and then we say rewrite the prompt to fix the issues, keep it to less than 60 tokens, return only the new prompt. And then we'll give it all of these different bits and pieces. This isn't going to work because we decided to ditch the temperature and so on. Yeah, this is fine. Yeah, so just checking that we've got. Yeah, perfect. We can actually just change that to an underscore now because we're no longer adapting that. If that doesn't work, we might have some issues, but perfect. Okay, and then we also score the prompt. We get a tick if it's good, a cross if it's bad, and so on. Again, we just do this by running it on the data set, and we do that by extracting the question, which we wrote up here in format question, which basically takes each row in our data set, it grabs out the question and all of the text and cleans it up, basically. It returns a mapping scoring too. Where do we get the different answers from? So they come from this data set, and this is the data set that we've loaded up here. If you want, we can do a quick, let's just see. Let's just print the data set itself. Okay, so it's a data set with these features, i.e. these columns, personality, and for this one, it's just going to be conscientiousness. It's got the question, and then it's got the 4 different responses. So if we look at just the first row, we can see that the personality is conscientiousness, as expected. That's what we split it on. We filtered it, basically. The question is, being careful can lead to better health outcomes. Okay, this is the one that we saw earlier. Let's just do oh, that's everything. That's not what I wanted. Let's get that right. This is the last one. There we go. Okay. The question is, over-organization can lead to stress when perfection is not achievable. Should I confront Mayana about their failure to meet the deadline? Okay, this is clearly some kind of context question. But this is okay, they don't need the context. Should we schedule a meeting, propose a plan, just give a casual heads up, but don't make too big of a deal out of it, or just let it slide? So clearly A or B are better here, right? And this is good. We're pretty happy with this. So this is just raw from the data set. And all that we're doing in our format question thing is combining this into a nicely formatted question to put into the prompt. Cool. So we've scored it, we've criticized it. Sorry, let's do this in order. we've prompted, we've got the wrong ones, we've criticized the wrong ones, we've rewritten better prompts automatically, we've scored them, and then we've kept the best prompt. So this is pretty simple, right? We are literally just generating new prompts based on a criticism that's automatically generated from our old prompt. And let's just run that so the functions are defined. And then I think we could just get started with this. So let's try running it. What I'm going to do is I'm going to say, let's give a base prompt, and the base prompt is going to be, you are a grumpy assistant. Oh, actually, no, let's say you are an assistant. Actually, no, let's change some things. Yeah, let's change some things. So you are a grumpy assistant. So this should be bad. Who is not very helpful. Choose. So this is a bad prompt, right? We want it to be helpful. We want it to be conscientious. Let's see how this goes. And up here, what I'm going to say is the goal is to pick the most conscientious answer, which goal is to pick the most conscientious answer between the 4 options. Wait, let's actually change this a bit more. You should criticize this prompt to improve the model's answering so that it picks options that are the most conscientious. Okay, fine, right, perfect, we'll run that. And then we will run this in full. So let's say best prompts. Perfect. And actually, I'm going to suggest we just do 2 rounds because we don't have tons of time, and we'll just have 2 prompts. And let's have verbosity. And then we'll do batch size of like 16 because I think, again, like we're kind of low on time. Actually, we'll do 20. No, we'll do 16. We're low on time. And hopefully we'll run this and it will be good. So we'll see the process at least. Would be good if I could spell verbosity, wouldn't it? Okay, right, cool. So it's on round 1 of 2 for 16 examples, 16 per batch with seed 42. Perfect. And that's printed right at the start. There we go, this little function here. And you could change it to be silent or light, whatever you like, for the different verbosity levels. Yeah. And we'll kind of let this run. So this is kind of like basically towards the end. What I will do while this is running is paste in the evaluation function. Oh, so somewhere we've given it temperature where we didn't give it temperature in. What I'm going to do is go up here and say yeah, fine, whatever. So temperature isn't actually used, but that's okay. Hopefully this will fix our little grumpy little error. Yeah, no problem. So you can't, I don't think, fine-tune Gemini. Because we're using an API, we don't have access to the model internals. So when you are fine-tuning, you are changing the model internals, you are changing the weights, you are retraining bits of it. Not all of it, hopefully, otherwise you're going to get model degradation. But yeah, when you are tuning your model, you have to have access to the model internals. Gemini is a closed source model, not an open source model, which means you cannot fine tune it. So the difference between training and tuning, I guess, they are both kind of a type of training in some sense, but training is like from scratch, teaching everything, whereas fine tuning, your goal is not to do that. So that's kind of the rough like overview, but yeah, you can't actually do any of that with Gemini. You could use Gemma, which is their open source model. I think it's pretty good as well. It's the biggest one, I think, is 24 billion parameters, which is pretty small, and it seems to get really good results. So I haven't played about with it myself, but I hope to soon. It came out very recently, I think about a month ago. So let's have a little look. So this is our prompt which we gave for the critique, and we told the base prompt is that you're a grumpy assistant who's not very helpful, and these are all of the different questions. And our criticism is correctly said, oh, the prompt's tone is counterproductive. It needs revision to guide the model towards conscientious answers. It should ask for helpful answers, framing the model as a proactive assistant. So this is role prompting. This is really good, not a grumpy one who gives poor advice. And so this is now our rewriting the prompt function. And we've given it the criticism, we've given it the original prompt, and then we've given it the option to write 2 candidate prompts. And so it's written some new prompts. The first one is, you are a helpful assistant, choose the best option A, B, C, D to solve the user's problem, be proactive. And then we've got candidate 2, which is, you are a helpful assistant, choose A, B, C, D to provide the best answer. And we can see that this is kind of looking a little bit better. It's only got 2 failures on when we did the scoring for the first candidate, and the original one had 3 failures, so that's kind of like a little bit better. And because we're doing this on a small batch size, we're not going to see big changes, right? But once we've got a better prompt, we will do some evaluation. And so let's write a quick evaluation function. So define evaluation pair, and this is the trait batch. So you could change this to use any of the other traits. We did it for conscientiousness, but you could do it for whatever you like. And then we will say base prompt. Actually, let's just take the base prompt in. Prompt A, we'll delete you. We will call this base prompt. And we'll call this. So this is still going, right? So the next prompt didn't do as well, interestingly. So it picked the best one, right? So round 1, it preferred, I think, candidate A. Yeah, it preferred candidate A, which got a score of 88%. That's pretty good. So we've got base prompt, we've got best prompt. And so what we actually also need is a function that checks the hit rate, i.e. the number of times it gets the correct answer. And so we need to define hit rates. And where I'm working to the clock here, this is going to be tight. Prompt batch hits equals 0 for row in batch. So for each question, we're going to get out yes, the question itself, format question row, and then we're going to say the letter equals extract choice. Yep, perfect. And then we're going to say if letter in yep, and then we're going to increase the hits, and then we're going to return. Great. So this is going to return us like a score, basically, kind of like what we've been doing before, but like a simplified version that doesn't do all of the printing and stuff. And then what we're going to do is we're going to say that base equals hit rate. Yep. And then we're going to say, okay, perfect. And then we're going to print them out. Perfect. And then we will return. Yeah, sure. We should probably have. I don't actually know why I wrapped it in a list. I don't think we need to do that. But you could if you wanted to. Fine. And so then we can get base improved equals eval pair, and then we're going to call this, yeah, this is DS. So this is, I think, going to run on the whole batch, and let's just run it. I mean, normally you'd have kind of, you'd shuffle your data sets and things. Let's just run it on 50, because otherwise it's 1,000 it's 1,000 different rows, so you don't really want to do that. Perfect. And we just want, yeah, that will do. Actually, that just gets out conscientiousness. And base prompt, best prompts. Yeah, perfect. Okay, so let's see. Okay, so we can see that it went through to round 2. The criticism was it lacks specific guidance on how to be conscientious. It doesn't define best. Oh, this is true. Add instructions. Blah 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 blah. Yeah, that's good, right? So you're a helpful assistant, prioritizing well-being. Yeah, see, this is really good. So we're still not mentioning being conscientious in the prompt. I don't think we were in round 1 either. Where's round 1? No, but this is okay. So actually the best score was only 0.69 here. Now the reason that we're not getting great scores is because our batch size is so small, so we don't really have the scale right, and there's an element of randomness that's probably ruined a lot of what's happening here. But this is okay. My suggestion is going to be that we take this one. But yeah, we can just continue actually with the results. So let's just continue with best prompt and base prompt. And so hopefully if we run this now, this might take some time. I'm expecting it to take, let's run it on 40. So I'm expecting it to take, okay, about 4 minutes. String indices must be integers. Okay, I'm not 100% sure what's going on here. Give me a minute and I will work this out. This should be okay. Let's try doing, instead of this, let's try doing select range 25. I think this might have solved the problem. Yeah, thank you for popping that link in there, Wax and Cheese. That is the link. If you want to go back and watch this, you're very welcome to. I know I've gone through things quite quickly, especially towards the end. What I am going to do while this is running is completed pipeline. Pipeline. All right, and we'll just commit that. So you can check this out if you're interested. It's on my GitHub. I think I've sent the link already. Yeah, it's pretty simple. This is basically just a notebook, very simple project. But I expect if you ran this at scale, you'd have really interesting and good results. If you read the paper towards the end, they say that prompt engineering, especially, they struggled with some of the traits. One of the traits I think is like psychopathic behavior, and they struggle to get more psychopathic behavior with prompting, which is a sign that the model was aligned well, right? And so this comes into like the model alignment side of things, which is super interesting, right? And you could say, well, could we change that? Probably we don't want to change that, right? We don't want a teacher to be psychopathic, but encouraging it to be more or less extroverted, for example, which is another trait. You might want it to be a really introverted model. That's something which you could try out. And I recommend, having a little bit of a play. You can, like I said, clone or fork this repository, take a little look. With that, I'm going to kind of wrap up. I'll let this run, and hopefully it will finish by the end. I'm expecting it to take maybe a couple of minutes more. I don't know if there's someone immediately after me, so while I wrap up, I'll chat through who's coming after me and what to look forward to. Also, in the meantime, I would really love to get feedback from all of you. It is very valuable. Because I want to know what I can do better, what you loved, right? If there's things about this that you thought were really good, I'd love to hear it. I've certainly had a lot of fun running it, and I know we did a lot of talking and not so much coding, so this is a little bit different to some of my streams, but if this is something that you liked, I can do more of it, or equally, if you'd like it to be more hands-on and do more coding, maybe build an app which uses this, that's something that we could do in the future, so give me that feedback. I'd love to know what I can do that would excite you next time. The link is mlh.link/GHW feedback. That's GHW for Global Hack Week. I think pretty much with that, we're going to wrap up. I'll keep this running like I said. And what I will do now is check out what the next stream is for you all. So we are on day 4. The next stream is actually not for a little bit, so we could overrun if this takes a little bit longer. Let's maybe. Oh, okay, this is really cool. I'm glad that we waited. Okay, so the next stream, I'll finish up what I was saying. The next stream is we've got an AI-powered ed tech hack part 1. I think that's with Carrie, and that will be at 1 p.m. GMT. I'm not 100% sure on what time that is in other time zones. That's probably like. Let me do some maths. 9 a.m. Eastern time, and then for those of you out in India, I think IST that will be. I want to go with kind of evening, 7 p.m., 7:30 p.m. Maybe someone else could tell me, but that will be in. Let's see. That'll be in 3 hours, so you've got loads of time. No problem, my pleasure. I'm glad that you all have enjoyed this. Some companies were training models to teach people to do bad things. Yeah, okay, yeah. So this is really bad, right? And this is the kind of thing that we don't want to happen. And this is part of the reason that I think these kind of streams are really important to do, because I want to educate people and learn myself as well about how we can actually build models that are safe. That, for example, right, we're teaching this model to be conscientious. And this is an important thing to be aware of when we're deploying models. How safe is it? How, reliable? How consistent? Can we actually say with certainty, yeah, what we're doing is going to be good? So this is something I care about a lot personally. And actually, I'm really happy that we got this to this point, because at the end of this stream, we started with a bad prompt, which was you're a grumpy assistant who is not very helpful. Choose A, B, C, or D only. And it got only 32%. On the same data set, our improved prompt got 92%. So that is a huge increase in performance. And admittedly, we started with a very bad prompt intentionally, right? So if we started with a decent prompt, we would see limited kind of returns. Probably, I think the paper got 30% improved performance, but 30% is still huge. I mean, we got 60% when we started with a bad prompt. So maybe a middling prompt is around 62%, 70%, which is roughly what the paper suggests. So I'm very pleased with this. I think this is really cool. And again, you could run this for much longer with much bigger batches, and you would get much better results as well. So yeah, I'm going to wrap up here. As always, ping me in the Discord if you have any questions or follow up. Check out this GitHub. Give me the feedback, because I love to hear it. And I think with that, I'll wrap it up. Check out Carrie's stream. That's in 3 hours on EdTech and AI. So a really helpful and informative one on how I hope that we can produce AI in a way that will actually be impactful in a positive way. So thanks all for joining, and I will leave it there. Have a wonderful Tuesday, and I'll catch you all later. Bye-bye.